Okay, ladies and gentlemen, little shout out going on to third hour. We're going to get working on sequences here. This is chapter 11. We're going to spend a couple days on chapter 11, sequences and series. We're going to take a little quiz on it on Wednesday. Okay. First of all, what is a sequence? It's a list of numbers in a particular order. Like this Fibonacci sequence. We've heard about this before. It's a sequence that you see in nature a lot, in different things. Basically, 1 plus 1 is 2, and then 1 plus 2 is 3, and 2 plus 3 is 5. Basically, to get whatever number you're looking at, like say 13, it's the sum of the previous two numbers. 5 plus 8 is 13. Not a typical sequence, but it is a sequence nonetheless. Sequences, terms in a sequence. A sub 1 just means the first term, A sub 2 means the second term, so on and so forth. The nth term basically is the last term, or the term you're looking for in a sequence, A sub n. If I want to find the 20th term, then n would equal 20. So A sub n would be the 20th term in this case. But if A sub n was 25, well, then A sub n would be the 25th term. So on and so forth. So we'll be working with a lot of A sub n's and definitely a lot of A sub 1's, the first terms. Arithmetic sequence in which each term after the first is found by adding a constant called the common difference. Now, common difference, we're going to use the variable d, common difference. So we look at this arithmetic sequence over here. From -8 to -6, we're basically adding 2. -6 to -4, adding 2. So on and so forth here. You see you can adding 2 every time. So our common difference in this case would be 2. But if I had something like 9 as my first term, then I went to 6, 3, and then 0. You can see that from 9 to 6, we're subtracting 3. But basically, you're adding a -3. -3. From 3 to 0, you're adding a -3. So your common difference in this case is -3. So we don't really necessarily subtract, we just add a negative. So it's still an arithmetic sequence. Geometric sequence. But it's found by multiplying by the same thing every time, the previous terms times whatever. And it can't be 0, so it's got to be a non-zero constant called the common ratio. Right there. And here's where we're going to be working with R. So if it's arithmetic sequence, you're working with D, the common difference. If it's a geometric sequence, you're working with R, the common ratio. You're multiplying. So adding up here, multiplying for geometric sequence. Anyway, you can see here from 4 to 8, and then from 8 to 16, you're not adding the same thing. So we're multiplying by something here. And in this case, we're multiplying by 2. Multiplying by 2, and so on and so forth. So my R in this case is 2. Your common ratio can also be negative, but the deal with that is that every other term is going to be positive, and every other term after that is going to be negative. And you can also have problems like this: 16, 4, and 1. I'm not multiplying by a positive or a negative here. Well, actually I am. I'm not adding is what I'm trying to say. 16 to 4, the common difference is 12, but between 4 and 1 it's not 12. So once again, we're not adding or subtracting anything. 16 to 4, you're actually dividing by 4, and 4 to 1, you're dividing by 4. Or you're multiplying by 1/4. 4 times 1/4 is equal to 1. 1 times 1/4 is equal to 1/4. And then finally, if I multiply by 1/4 again, I would get 1/16. In this case, my common ratio is 1/4, a fraction, and you'll see that once in a while. Find the next 4 terms in the arithmetic sequence, and then number 2 is find the next 4 terms in the geometric sequence. I want you to pause here and try these on your own real quick, and I'll give you the answers after you unpause it. Well, 55 to 49. Looks like we're going down by 6's. So I'm adding a -6. -6. So my common difference is -6. I'm adding -6 each time. So 43 plus -6 is 37, 31, 25, and 19. It's important to recognize that that's a -6. You're going down. I'll find the next four terms in the geometric sequence. Well, between 3 and 12 is 9, and between 12 and 48 is 36. So we're definitely not adding. So it's going to be a geometric, like they say. And 3 times 4 is 12, and 4 times 4, or 12 times 4 is 48. So this one I get 192, 768, 3072, and 12,288. Got a couple formulas for you here. Finding the nth term of a sequence. Now the first one here, the nth term of an arithmetic sequence. This is where you're adding something every time. You can find the number of term by using the formula. Well, first of all, a sub n is the term you're looking for. So if I'm looking for the 20th term, it'd be a sub 20. If you could write it that way if you want. A sub 1 is my first term. D is the common difference. And then n is the number of term you're looking for. So if I'm trying to find the 20th term, I'd plug in 20 for n. So this is the number of term in sequence. Number of the term in the sequence. If I'm looking for the 10th term, I'd plug in 10 for n. Then it would be a sub 10 if you wanted to write it that way. So looking at this problem, here's our formula for the nth term in a arithmetic sequence. The table at the right shows the typical costs for a construction company to rent a crane for 1, 2, 3, and 4 months right here. 1, 2, 3, and 4 months. If the sequence continues, how much would it cost a crane? How much would it cost to rent the crane for 12 months? Well, I want to go 12 months. So right there, I can say this. I want the 12th term in the sequence. So n is going to be 12. A sub n is the number of the term we're looking for. So you could say this is the a to the sub 12 or a to the 12th. But a sub 1, which is my first term in the sequence here is 75,000. Okay. My common difference is the next thing I got to find. Okay. Well, what's the difference between 75,000 and 90? You'd subtract. And we end up with 15,000. Now, just to make sure, what's the difference between 90,000 and 105,000? Once again, it's 15,000. So, a sub n is going to equal my first term, which is 75,000, plus, I want to find the 12th term, so I'm going to plug in 12 for n, minus 1, times the common difference, which is 15,000. Now it's just a matter of simplifying and solving. 75,000 plus, well, 12 minus 1 is 11 times 15,000. So this is 75,000 plus 165,000. Adding those two together, we get 240,000. So renting this crane for 12 months for a year, almost $250,000, $240,000. Write an equation for the nth term of the arithmetic sequence. So we don't know what the nth term is, but we do know some things. We know what the first term is. We know that's 8. We're adding, looks like 9 every time. Yeah, I think it's 9. So my common difference, D, is going to be 9. So we're going to plug those two things in there. We don't know what n is, so we're just going to leave n as n. A sub n equals, well, my first term is 8, plus n minus 1 times my common difference of 9. Now, we're setting this up so we could find any term in this arithmetic sequence. So basically we're going to simplify by using the distributive property. 8 plus, well, n times 9 is 9n, and then 9 times negative 1 is negative 9. Now you can see that I have 8 and negative 9. I can simplify that down to a sub n equals 9n. I'll put my variable term first. 8 and negative 9 is negative 1. So there's the formula I could use for this arithmetic sequence. If I want to find the 20th term, I'd just plug 20 in for n, multiply it by 9 and minus 1, and I'd be done. So that's how we write a little formula for the nth term of this arithmetic sequence. Okay, turning back to the front page there again, looking at a sub n, the nth term of a geometric sequence here. We're going to work with geometric sequences, multiplying here. So we're not adding, we're multiplying. Now, once again, we have the a sub 1, that's the first term. N right here, it's actually n minus 1, but n, it's an exponent, r to the n minus 1 power. You can put the n minus 1 in parentheses if you wanted to, but basically n is the nth term in the sequence that you want to find. And then r is your common ratio. Okay, so we're going to flip it back over now to number 5 here. It says find the 8th term of the geometric sequence, for which a sub 1 is 3. They're just telling you it's 3, and r equals negative 2. And the key is they want you to find the 8th term. So right here, n equals 8. A sub 1 is r. That's my first term, and my common ratio is negative 2. So basically, we're just going to plug things into the formula here. A sub 1, r to the n minus 1 power. That's an exponent there. So a sub 1 is 3. Put that in parentheses because I'm multiplying it by r, which is negative 2 to the 8 minus 1 power. Now the 3 here is not to the 8 minus 1 power, it's the negative 2. So when you do this problem, simplify it down a little bit, it's going to be 3 times negative 2. 8 minus 1 here is 7. And once again, the 3 is not to the 7th power. The negative 2 is. So I'm going to take negative 2 to the 7th power. Negative 2 to the 7th power is negative 128. And finally, multiplying 3 times negative 128, I get negative 384. 384 right there. Okay, that's about enough. We will finish this up tomorrow. Don't forget to take your quiz. You took your notes. Make sure you take your quiz so you can get a little credit. And we'll see you guys tomorrow on the flip side. A little shout out going out to Paige. How you doing, Paige?